Cadets, now in the last video of UPSC class, I taught you matter and their classification. So matter can be divided into two ways. First one is on the basis of physical property and second one is on the basis of chemical property. So the chemical, in the last video only full chart diagram I have made here, flow diagram I have made here. Now today I have to complete this one, that is why chemical classification I am not writing, but in the last video I have made it. So under physical classification, matter can be divided into 5 categories: solid, liquid, gas, plasma and Bose-Einstein condensate. So in the last video only, how many types of solids are there? There are 2 types of solid: amorphous solid and crystalline solid. So I have completed the amorphous solid and crystalline solid. Under crystalline solid, 4 are there: ionic, covalent, metallic and molecular. How many types of solids are there? 4 types of solid: ionic solid, covalent solid, metallic solid and molecular solid. So with their example I taught you. Now today I am going to teach you liquid. So my planning is to complete the liquid, gas, plasma and Bose-Einstein condensate today only, so that the next video I should teach you the chemical classification of matter, that is pure substance and impure substance. So dear cadets, now liquid. What is the liquid? Liquid is nothing but a physical state of matter which has fixed volume but no fixed shape, and they have got the flowing property. Now try to understand in the liquid what is there. There are so many properties, you know this one. Interparticle spaces are more. Now interparticle attractive force is weaker than solid but stronger than gas. So just see, liquid is in terms of interparticle attractive force, they are in between the solid and gas. So that is why they have got the flowing property. Interparticle attractive force is not very strong. That is why their shape is also not fixed and they have got the flowing property. The important aspect of liquid is, just try to understand, there is a one term, interconversion of state of matter. Interconversion of state of matter. That is the most important thing. So try to understand the meaning of interconversion state of matter means conversion into one state to another. Conversion from one state to another state. One state to another state. That is known as interconversion of states of matter. In interconversion of states of matter, there are various processes. So what are those processes? Just see. If solid is getting converted into liquid, this is liquid. So what is the name of this process? This process is known as melting. Okay, conversion of solid into liquid, that is known as melting. And now melting can only be taken place when heating is there. Heating is there, then only. Similarly, when liquid get converted into solid, so what is the name of this process? This process is known as freezing. Freezing. And when it will be taken place? Cooling. Upon cooling, it will be there. When you cool, then only liquid will be converted into solid. We can say like that also. If the temperature of the solid is increased, it will be converted into liquid. Similarly, when the temperature of the liquid is decreased, it will be converted into solid. So the conversion from one state to another state, that is known as interconversion of states of matter. Further is also there. Suppose liquid, you are heating the liquid. So it will be converted into gas. What is the name of this process? This process is known as vaporization. What is the name of this process? Vaporization. Similarly, when gas is getting converted into liquid. So what is the name of this process? This process is known as condensation. What is the name of this process? Condensation. So try to understand here. Upon heating only liquid will be converted into gas, and upon cooling only gas will be converted into liquid. Similarly, there is one process when solid is directly getting converted into gaseous state. Gaseous state. So what is the name of this process? This process is known as sublimation. What is the name of this process? Sublimation. Similarly, when gas is getting converted into solid state, so what is the name of this process? The name of this process is also precipitation, or you can say sublimation. Both are same thing, sublimation. So try to understand here. So the property of liquid is no fixed shape, but fixed volume but no fixed shape, and flowing property. Interparticle attractive force lies in between solid and gas. Means what is there? Interparticle attractive force is weaker than solid but stronger than gas. And now if you see the gas state, suppose gas is there. So to read means all these processes, let us have something idea about the gas also. What is the gas now? Gas means number one, no fixed shape, no fixed volume, and third one is interparticle attractive force is negligible. Interparticle attractive force is negligible. So in this state of matter, what is happening? Shape is not fixed. This is the only reason, that is why gas can acquire the shape of any container in which it is kept. Now volume is not fixed. Why volume is not fixed? Interparticle attractive force is negligible. That is why it can acquire any amount of volume. Their particles are free. So now all the three states are over. Means solid, liquid and gas. Now let us have idea about the interconversion of states of matter. So if you see carefully, so how many processes are involved in the interconversion of states of matter? Conversion of solid into liquid. What is the name of that process? Melting. Conversion of liquid back into solid, freezing. Conversion of liquid into gas, vaporization. Conversion of gas into liquid, condensation. Similarly, conversion of solid directly into gas, that is sublimation, without undergoing liquid state. Similarly, conversion of gas directly into solid, that is known as precipitation or sublimation. So now this is the time to tell you something about this one, means these processes. What is the melting point? What is boiling point? And this is vaporization, and the process name is vaporization occur at the boiling point of liquid. The process is vaporization, or here you can write boiling. Okay, so we'll have idea about all these things. So dear cadets, the first process is melting. So what is this one? Process of conversion of solid into liquid. The process of conversion of solid into liquid, that is known as melting. The temperature at which at which at which melting take place is known as melting point. Okay, so just try to understand the process of conversion of solid into liquid, that is known as melting, and the temperature at which melting take place, that is known as melting point. Remember, melting point is the characteristics of solid. No two solid will have the same melting point. So here you can write melting point is the characteristics of solid. Characteristics of solid. No two solid will have same melting point. There are some more aspects here. Always remember, melting point means for the pure substance, melting point will be sharp only. There should not be mixing of other substance. Means pure substance will have sharp melting point. And try to understand, this melting point is the characteristics of interparticle attractive force also. Suppose one substance is there, so just see right here, high melting point. So what is the meaning of high melting point? Strong interparticle attractive force. Strong interparticle attractive force. And here what is there? High melting point. Here what is there? Low melting point. Low melting point means weak interparticle attractive force. Now try to understand here. Means indirectly what we can say? Melting point is the magnitude of, means on the basis of melting point we can judge the magnitude of attractive force. High melting point means what? Interparticle attractive force is strong. That is why their melting point is more. Always remember, any solid can only be melted when their all interparticle attractive force gets broken. So if interparticle attractive force is strong, it means you have to supply more amount of heat, then only their interparticle attractive force will be broken. So melting point, on the basis of melting point we can judge the interparticle attractive force magnitude also. So this is the important point. One more important point is here, just try to understand. Whenever any solid gets melted, so when the melting point of that solid reach, at that time what is there? For some period of time, the reading of thermometer remains constant until entire solid gets melted. Okay, suppose one substance is there, its melting point is 10 degrees Celsius. So initially what would be there? 1 degree, 2 degree, 3 degree, 4 degree, and now the reading of thermometer will reach to the 10 degree. So when it reaches to the 10 degree Celsius temperature, at that time for some period of time the reading of thermometer will be stagnate. Why? The reading of thermometer will stagnate till entire attractive force of interparticle attractive force of that solid gets broken. Okay, so the question arises here, where that supplied amount of heat has gone? Even though the reading of thermometer remains stagnant, but you keep on heating, it doesn't mean that you have stopped the heating to the solid. You start heating that solid, nevertheless reading becomes stagnant. Remember, at the melting point of any solid, the reading of thermometer remains constant for some period of time until unless entire attractive force of that part means solid, interparticle attractive force of that solid completely gets broken, and that amount of heat which you have supplied during that time, that is known as latent heat of fusion. Latent means hidden. So here new term has arises. What is this one? Latent heat of fusion. Latent heat of fusion. Fusion, or you can write here melting. Melting is also known as fusion. Here you can write fusion also, F-U-S-I-O-N, fusion. So what is the meaning of latent heat of fusion? This is the amount of heat which is supplied to the solid at their melting point and at atmospheric pressure. Are you getting my point or not? What is the latent of fusion? Latent heat of fusion is amount of heat supplied to the solid at the melting point of that solid and at atmospheric pressure. Now in the more polished way, how can you define this one? The amount of heat supplied to the 1 kg of solid at their melting point, and at 1 atmospheric pressure. What is that one? This is the latent. Latent means hidden. This is the latent heat of fusion or melting. So as far as one process is concerned, everything I have taught. Now the next process is conversion of liquid into gas. So here the new process you will write, I will edit here only. So the next process which is involved in the interconversion of states of matter, that is known as boiling or vaporization. What is this one? The process of conversion of liquid into gas. And the temperature at which boiling take place, that is known as boiling point. Okay. Boiling is the characteristics of liquid. No two liquid will have same boiling point. So just like a melting point, this boiling or vaporization is also the characteristics. No two liquid will have same boiling point if they are pure. If they are mixed with some other substance, then they may have. So always remember, just like a melting point, boiling point is also the characteristics of pure substance. Now this boiling point is the measure of the characteristics of interparticle attractive force of the liquid. If boiling point is high, so what is the meaning of high boiling point? The interparticle attractive force of that liquid is strong. Similarly, if boiling point is low, what is the meaning of low boiling point? The interparticle attractive force is weak. That is why their boiling point is less. If boiling point is less, it means you have to supply less amount of heat to break that interparticle attractive force. So now try to understand. Just like a solid, suppose you have taken liquid in the beaker and you are heating this one, and one thermometer, laboratory thermometer, you kept upright inside the liquid. Then what would be there? Just see. When the boiling point of that liquid will reach for some period of time, the reading of thermometer will remain constant. So same thing, why it remain constant? Because at that time the supplied amount of heat is utilized to break the interparticle attractive force which is present between or among the liquid particle. So that is why even though you are supplying heat, but reading will remain constant for some period of time. So where does that heat energy go? That heat energy is involved to break the interparticle attractive force, and that heat supplied is known as latent heat of vaporization or boiling. So now in a standard way, how can you define the latent? Latent means hidden. Latent heat of vaporization, this is the amount of heat required. What is this one? The amount of heat energy required for 1 kg of liquid to convert into vapor or gas state at their boiling point and in 1 atmospheric pressure. So the amount of heat required to convert 1 kg of liquid into gaseous state at their boiling point and at 1 atmospheric pressure. So this is known as latent heat of vaporization. Now the next process is sublimation. So the conversion of solid directly into gas, that is known as sublimation. So dear cadets, now sublimation. What is the sublimation? The conversion of solid directly into gas without undergoing liquid state. Okay. So just try to understand. So far what we have discussed? Conversion of solid into liquid, liquid into gas. Now there is one process in which the solid directly getting converted into gaseous state without undergoing liquid state. Such process is known as sublimation. Do you know what kind of substances are undergoing sublimation? Substances, basically solid substances which have got weak interparticle attractive force. Substances which have got weak interparticle attractive force, they undergoes sublimation. They undergoes sublimation. Are you getting my point or not? So if their interparticle attractive force is very weak, then only they will undergo sublimation. What kind of substances? Example is also written here. Naphthalene. Here what is there? Ammonium chloride, iodine and benzoic acid. These are the substances which undergo sublimation. What is the next one? Next one is freezing. So just see, the conversion of solid into liquid, that is known as melting. Similarly, conversion of liquid back into solid, that is known as freezing. So now try to understand the temperature at which liquid gets freezed into solid, that temperature is known as freezing point. And remember, during the melting, whatever amount of heat is required to convert solid into liquid, same amount of heat energy will released when liquid gets freezed into solid. So what we can say, melting and freezing point is, or melting and freezing processes are just opposite to each other. In the same way, we can explain the vaporization and condensation also. Vaporization and condensation is just opposite to each other. So dear cadet, one more process is condensation. What is the condensation? Condensation of gas means conversion of gas into liquid. What is the condensation? Condensation is the process in which gas get converted into liquid. And now try to understand the temperature at which condensation take place. That temperature is known as condensation point. Okay, and remember, during the boiling of any liquid, whatever amount of heat energy is required to boil that substance, same amount of heat energy is released during the condensation of that substance back into liquid. So try to understand, heat energy is released equal to concerned liquid boiling point. Concerned liquid boiling point, heat energy is equal to, means the heat energy is released equal to their boiling point. So just see what we can say. Number one, melting is endothermic process, but freezing is exothermic process. Boiling is, or vaporization is endothermic process because heat energy needed. But what is the condensation? Condensation is exothermic process because heat energy is released. So sign will be different. Suppose the boiling point of one substance is 100 degrees Celsius, boiling point. So what would 100 degrees Celsius means? 100 degrees Celsius temperature is required. And what about the condensation point? means same amount of heat energy will be released when gaseous state of that substance gets converted into means liquid state, means conversion of water into water vapor. What is that one? Boiling or vaporization. Conversion of water vapor back into water liquid, that is known as condensation. So whatever amount of heat is needed to convert water into water vapor, same amount of heat energy will be released. Conversion of water vapor back into liquid water. So in this way this process is also over. Interconversion of states of matter is over. Dear cadets, there is one more aspect, effect of pressure on melting point and boiling point. So just see, what is the effect of temperature on melting point and boiling point? Already interconversion of states of matter we have studied, that is the effect of temperature only. Solid can be converted into liquid upon increasing the temperature, liquid can be converted into gas on increasing the temperature. So that is the effect of temperature. What is the effect of pressure? Try to understand. There are different kinds of solid. One type of solid which on melting gets contracted, means if solid upon melting gets contracted, so its melting point will decrease on increasing the pressure. So basically solids are two types. One type of solid which gets contracted upon melting. Similarly, another type of solid which gets expanded upon melting. So try to understand the solid which gets contracts upon melting, their melting point will decrease on increasing the pressure. Similarly, if solid expand upon melting, then its boiling point will increase on increasing the pressure. So the solid which contracts on melting, their boiling point will decrease by increasing the pressure. But if solid gets expanded on melting, so their melting point will increase on increasing the pressure. So this is the effect of pressure on melting point and boiling point. Boiling point of water increases on increasing the pressure. Just see, the boiling point of liquid, especially water, increases with the increase of pressure. This is the only reason, that is why in the pressure cooker food cooked easily or early. But see, when we go to the mountains peak, there what is there? What would be there? Their pressure is less or not? So it takes a lot of time to cook the food. Why? Because any liquid can only boil when their vapor pressure become equal to atmospheric vapor pressure. So at the mountain peak, what is there? Pressure is less. So very easily that liquid boiling point, means their vapor pressure become equal to atmospheric pressure. That is why what is there? In high altitude areas, food cooked early. Correct or not? Because that liquid will boil early, because that liquid vapor pressure very easily become equal to vapor pressure of atmosphere. And this is the only reason, that is why in the pressure cooker what is there? Pressure cooker, what is? It is enclosed from all sides. So what is there? Pressure is very high. So concerned liquid will boil early. That is why the boiling point of water increases on increasing the pressure.